Hey guys, welcome to our next lesson and our last, I'd say, final lesson for this course in regards to techniques for artists. And this technique is called perspective, which is how to create the illusion of 3D space on a 2D piece of paper. It was developed during the Renaissance, and since then it's really been used all the time by artists to make anything have a sense of depth. Okay? So most of you may be familiar with this, but if you're not, this is a brief overview of everything that you will need to know for perspective to create your backgrounds. Okay? So what is perspective? Well, perspective takes the scientific analysis, I'd say, of how the human eye works, which is two eyes that converge at a point. Okay, so our eyes meet at one point. And our eyes are on an eyed level, right? So the level, like you see here, in which we look, determines if we see above or below an object, or land, or a plane, or a car, or whatever it is, right? So anything above our line of sight or our range of vision, we will see underneath. Anything below, we will see above. And why is this important? Well, if we understand how the eyes operate and how we see things when we look at things, then we can understand how to create the illusion of 3D space, right? So take, for instance, these cubes, right? So if it's below my eye level, okay, then it's going to see the top, and if it's above my eye level, we're going to see the bottom, right? And here, if we take an above view of the human eyes, it's really simple drawing, but this is what I meant earlier, when our eyes converge at a point, right? We're looking down the center at an individual point, but our eyes are actually meeting at that point, right? But it's always along our eye level, okay? So why do we need to know this? Well, in the Renaissance, they created this method to create the illusion of space called perspective. And they represent the human eye level with this line that you see here called the horizon line. And it's kind of like where the sky meets the earth, okay? And on this horizon line, it's always on the horizon line, is a point, disregard that, sorry about that, guys, is a point that our eyes converge on. So as I said before, our eyes converge at a point, and that point that you see here in red is called the vanishing point, where things vanish from our point of view, because as the further they get away, they get smaller, and the further they get away, they disappear into the atmosphere, because there's literally atmosphere between us and the object the further it gets away, okay? So here, let's talk about the cube. So the cube we were talking about earlier, if I were to draw a cube here, just like I'm drawing here, a square in the bottom of the box, it's pretty flat, right? Especially if it's the same square and square, right? It doesn't look like it's moving away from us into space. But if we utilize this vanishing point where our eyes converge, and we go from each point of the cube to this vanishing point, and you use a ruler so it's nice and straight like I'm doing here, unlike the previous one that I just drew, which was curved, okay? Use a ruler all the time. From each corner of the cube, you would draw a line to the vanishing point. You decide where the box ends. You draw your horizontal line, which must be perfectly horizontal, okay? If it's crooked, it will look weird, okay? It's not going to look correct. It should be parallel to the line above it. Once you are done drawing your lines that go to your vanishing point, here the red cross, right? Then you would erase your pencil line. So as you see here, we actually have a cube that looks like it's moving away from us, is above our eye level, and has the illusion of 3D space. If we take this cube and move it to the right, like I'm doing here, again, using a ruler for everything, I'm trying to, okay, then we actually see the side of the cube as well. It's not directly above us, right? So now we have 3 points to go to the vanishing point. So from each corner of the cube, we're going to draw a line to the vanishing point, because as things move away from us, they get smaller, okay? If things move away from us, they got bigger, it wouldn't make sense logically, okay? So as these move away from us, they get smaller to the vanishing point. And again, you decide how large you want your cube, if you want it small, long, whatever, and you draw your line. Now, if your lines are crooked, like you see here, it just looks wrong unless the shape is supposed to be crooked, like a star or something like that. It should be parallel to the line next to it in that same plane, okay? So here, as long as our lines are perfectly straight, okay, we have the side and the bottom, Okay, and see if it's crooked, it just looks wrong, unless, again, that is the shape you are trying to make. If this was a spaceship or something, you most likely will start off with a cube, but change the shapes to match the size of the ship, the shape of the ship, and whatever you would need, okay? And when you're done, you would erase all your guidelines, like I'm doing here, and as you can see, we have the bottom of the cube and the side of the cube, okay? So now, what if something is below our eye level? Well, if it's below our eye level, we're going to draw the square, the square or whatever shape. Could be a triangle, could be a sphere, could be whatever it is. If it's a circle, it's going to be like a giant cylinder. If it's a triangle, it's going to be a very elongated triangle, right? Star, it's going to go into the distance. But everything works the same from every corner. Okay, so this is what it would look like if the box is transparent here. From every corner, you would go to the vanishing point. Right? So this was a block of ice and you saw the bottom. This is how you would draw it, so that you have your vertical lines perfectly vertical and horizontal lines perfectly horizontal, but then the ones that are moving away from us, such as the side lines there, are going to go to the vanishing point. And here you would essentially see what would be a cube, right? An ice cube. Okay? So that is called one-point perspective, where everything goes to one vanishing point. Okay, so what happens when we have the side of the building or the edge of a building or ship or a car or something? Okay, one point like this won't cut it. Okay, what happens is things move away from us. Technically, they're moving away from us at two different planes, right? And each plane is going to go to its own vanishing point. Now, when this happens, it could be 2 point, it could be 3 point, it could be 4.5 point is when you have like a fisheye lens, right? So these are things that change the game. We're getting more complicated here, right? But just to keep it simple and just to talk about 2-point perspective here, what I would like to point out before we go ahead is that this would be really only used if you have the corner of a building, the corner of a ship or something, okay? And when we do this, we're going to take the one vanishing point we had and split it into 2 vanishing points, okay? Each of those vanishing points must still be on the horizon line. That does not change, okay? So let's go ahead and we're going to make a cube above our eye line that has 2 plateaus, 2 planes going to 2 separate vanishing points. Okay, so the first thing you're going to do is start off drawing the corner, whether it's a ship, a cube, a building, a floating car, whatever. And once you have this corner, you're going to draw from each the top and the bottom of the line to each vanishing point. Okay, so you see here, I'm going to each vanishing point and I'm drawing from the top and the bottom of the corner. Okay, so it looks like we're looking at 2 walls now. If this building extended beyond and was really tall, it might go off the page, but the lines would still go to the top of the building. You decide how wide you want your cube. You draw them perfectly vertical. And then the horizontal lines that are moving away towards the vanishing point continue that way. Now here's where it gets a little tricky. You have to continue to go from the corners. So if you go from the bottom of the new corners that were just created, you see how they crisscross? That creates the back corner, okay? So when you're looking underneath, something's above you and you're looking underneath, right? You want to take the corner on the left and go to the vanishing point on the right, and vice versa. The corner on the right to the vanishing point on the left. So whatever you see on the opposite corner, you want to crisscross to the opposite vanishing point, if that makes sense. Let's do it one more time where it's below our eye level, and the same thing will be applied, but it will be above the box, okay? So again, you're going to start off. We'll move it off to the side here a little bit so that you can see how it changes the sides that you see. Okay, so we're going to start off with the corner, and from the top and the bottom of the corner, we're going to go to the vanishing point. Okay, no matter how close you are to the vanishing point, you still go to the vanishing point. Okay, if you're so close that you don't see it, you don't see it. Top and the bottom to the vanishing point. Okay, you decide how wide you want this cube to be. Building, whatever. Okay, make sure that your line's perfectly vertical. And then from the top, since this is the top corners, you're seeing above it, you're going to crisscross. From the left, you're going to go to the right vanishing point. From the right, you're going to go to the left vanishing point, and it creates that back corner of the cube that you then have to show the back of the cube. And it shows that this plateau on the left is moving smaller and getting smaller and moving away from us, and the plateau on the right is also getting smaller and moving away from us towards that vanishing point. Okay. okay? If that doesn't make sense, just watch the video again, pause it, maybe rewind it, okay? And take a look at that one more time. Now, if you wanted to add shadows or shading or anything like that, a cast shadow of the box, it would still follow perspective. So if I take this and I actually look at the same plane that I've already created from the sides, right? I then take the top angle there and I go to the vanishing point on the right, again crisscrossing because it's an angle towards there, so the top of the shadow there technically would go to the right vanishing point, okay? If the shadow was being cast towards the back vanishing point, then it would move towards the left vanishing point, okay? And here it would be for 1 point perspective, shadows would be the same thing. So if we actually take this ice cube that we have below and just use the bottom of the bottom rectangle, I guess you could say, of that ice cube, that would be the shadow for the one above it. Or here we can create a shadow for the cube on the right. So here I make a line and I do it from the corners back to the vanishing point. I decide how long I want it, I erase the rest, and then I would fill it in solid black or make it a transparent shadow, whatever it might be, so it looks like the cube above is casting a shadow onto the floor, and that shadow is also in perspective. Everything follows perspective, so make sure you take a look at the handouts and stuff like that and the PDFs that are in your content folder, because it does go through that quite evidently. Okay, so here again is the shadow for the 2 point perspective, and here is the 1 point perspective shadow. So people, cars, planes, grounds, whatever the case may be, follow perspective, and they must follow perspective. So if someone is standing with their side to you and you see one eye is closer to you, that eye will be larger than the eye that's further away, because technically it's going to a vanishing point. Okay, so that's the main perspective that will be helpful for you for creating your background for this project. Okay, the only other technique that I think you really are going to need to know is how to create like windows or fences or telephone poles or something like that that is repetitive, that is moving away from us on the street. Because as things get further away from us, not only do they get smaller, but they usually get closer together, because literally they're blocking the next one's view as they move further and further away. Okay, so keep that in mind. So there is a technique that you can use to kind of mathematically create a pattern of telephone poles or fence posts or whatever it might be that go into the distance and get progressively closer together and smaller. And that's what we're going to take a look at this technique on how to do that now. Okay, so again, we have our horizon line right here, okay, and our vanishing point. Let's use 1 point perspective for this. Technically, it will be 2 point, but the second point will be off the page, and that can happen. A vanishing point can be off the page because it's not within view, okay? So if it's to the left, it could be above, whatever the case may be, okay? So here, let's say we have a road right in front of us, okay? So we have the width of the road, which we're standing on, going to the vanishing point, and it dissipates and disappears as it goes into the distance. And to the right, let's place like a little house here. Maybe we're on the Great Plains or something like that. And we're going to create the side of the house. So here I'm going to draw from the corner, the bottom corner, and the top corner. Here's the corner of the house. You should start with that. And then from the top and the bottom, you draw to the vanishing point. I decide where it ends, and I draw that vertically up parallel to the corner. Okay, and now this way I technically would be going to another vanishing point, but in this scenario, since we're doing 1 point perspective, we can just draw them perfectly horizontal, just like we did with the cubes in the 1 point perspective. Now if I have a triangular roof, I just draw the lines on a diagonal on what I want the angle of the roof to be, but then the top of the roof must go, just like you see here, to the vanishing point. Okay, so the top point of the roof will go to the vanishing point. Okay, and then when I'm done, I erase my guidelines. Okay, once this is set, if you wanted to put a window or something like that in, you could, and you would just create the side of the window and go to the vanishing point. Okay, anything goes to the vanishing point. Okay, so for things like telephone poles, fence posts, things like that, let's say we have this very nice fence post here. Okay, and we want to go along the road here to the vanishing point. Okay, I'm going to draw from the top and the bottom of our lovely fence post a line, a guideline, to show me how tall the fence posts will be as they get further away from us. Okay, and now I'm going to draw my second fence post. Okay, now I could just draw them in like I have here, but the problem is they're not going to be evenly spaced out and get mathematically closer together as they would in real life. So to figure that out, what I do is I measure the top or the height of the fence post, and I find the halfway point. Okay, once I find the halfway point, I draw a guideline from the center, the halfway point of the first post, to my vanishing point. Okay, once I have that, I'm drawing in red here so you can see this is the center point. Okay, I can use that against the first width that I set with my second post there. Okay, so my first post, I set my second post there, the line, and where this center line crisscrosses of that second post, as you see here, okay, that creates a cross. That I'm going to use with my ruler to draw a line diagonally from the top of the first post through the center mark, like you see there, through the center mark, the cross of the second post. Where that diagonal line hits the ground, that is where the next post is going to be. Okay, so that gives me the exact distance of where the next post is going to be. So you see, so now I have 3 posts. Now by creating that, I've created a new crisscross with that center line on my third post. So now I can continue and repeat this method along the way to create all the posts. So here is my new crisscross right here, my new cross, and I'm going to go from the second post through the crisscross of the third post, okay, and where that hits the ground, that's going to be my fourth post, okay, and then I'm going to go back one to my third post, and I'm going to go again through the new crisscross in my fourth post, and where that hits the ground is my fifth post, and you just keep going and going and going until basically they're so close together you can't tell. Okay, and you just go back one, go from the top corner through the center cross, and then you go up one, and you see how they're evenly spaced out, and it looks like they're moving away from us. Now if they're like the first post where they're rickety and not totally perfect, you can then take these perfectly straight lines and just use them as a guide as to where it should be, and then kind of edit them and add your details and stuff like that. So here I'm going to draw the top, I'm going to draw the bottom, and the side is going to go to the vanishing point. So you have to follow that, and the top too as well, just like you would with the cube. It's going to go to the vanishing point. And I'm going to draw my rickety fence post. Now if I wanted to use that center guide that we put in as where the crisscross post is going to be, you can, and you can make it rickety or like a piece of wood where it's not perfectly straight. That's fine, but stay along that guideline. If you don't, you can just erase your guides and you have individual posts here. Now this is applicable for a lot of things. Telephone poles, bricks, if you do these like stones, okay, each of these sections would be a stone, and you do 2 rows, and once you do 1 row you can draw them all straight down, right, for all the bricks, and then you would do the second row that would be staggered, so it would be wherever the center of the first row is, then the second row would be in between, right, and then you would continue that every other row, and then you would have your bricks. Or windows, if you wanted to do these as windows, you would have the top and the bottom, you would keep those guidelines, and the center line could be like where the 2 panes of glass meet, okay, and you'd put that on houses or whatever. And you can utilize this for many things as you go forward, especially in buildings and your backgrounds for trees, okay, if you have a bunch of trees in a row like an orchard or things like that. It's very useful for things that line up, including windows and everything else. Again, so anything that is moving away from us to the distance must go to a vanishing point, okay? Anything that's perfectly vertical must be perfectly vertical and parallel to whatever the box that's associated with is, okay? If you have any questions with this, please definitely shoot me an email or ask it in the voice thread. I'm going to go over this as well in the voice thread and be maybe a little bit more specific with some examples, and I have the PDFs online that I want you to read that explain this even further. So I'm hoping with this, the voice thread, and the PDFs, you'll have a pretty good understanding of perspective, that when you go to create these backgrounds for our projects, you're not totally lost, because I know that this can be a very confusing subject and can throw people off balance really easily. If you're a mathematical person, you might love this part of art. If you're an art person that's really creative and likes to abstract things, this might be something that's totally off your rocker and you can't stand it. Do your best though, either way, and try to make the best of it. I think for the most part, I think this explanation with coupled with everything else will definitely give you what you need. And again, good luck, have fun, enjoy it, and if you have any questions, definitely shoot me an email. All right?